All right, so we're doing lesson 20, and we'll start off today with the second puzzle. The second puzzle, you actually have to go into your functions block and click on the distance function, okay? And in the distance function, they'll give you a few things. They're gonna ask for the four inputs that you need is your player's X, your player's Y, your character's X, and your character's Y. Now this is kind of nice because we don't have to worry about both target and danger. Your character is both your target and your danger. And our overall goal is to figure out the distance between our player and our character, okay? And once we get the distance down, then we're gonna use that inside the Clyde function, okay? So here's what I have up here, and some of you that are in middle school math 2, you're gonna eventually learn Pythagorean's theorem, which says that if you know the height of a right triangle and square it and add it to the base of a right triangle squared, it will equal the diagonal or hypotenuse squared. So in other words, you can see from my lovely drawing here that if I want to find this distance right here, if I make a right triangle, which I did just by drawing lines, if I find the height of this right triangle, the base of this right triangle, I can find this distance right here. And we're going to do that by using the player's X, player's Y, the character's X, and character's Y. Okay? And those of you that are in middle school algebra, this year, whether you've done it already or soon and very soon, you're going to learn this formula right here. And this formula is called the distance formula. You can find the distance between any 2 points on the coordinate plane as long as you just plug in this formula. The nice thing is we don't have to call this y2 and y1. What we're calling this actually is our character's y and our player's y, and our character's x and our player's x. So we give them specific names. Rather than just two random points that we have and trying to find the distance between them, what they do is they call it y subgroup 2 and x subgroup 2. That's 1 point. And y subgroup 1 and x subgroup 1, that's another point. Okay? So here's how we do this. Going with Pythagorean's theorem. In order to find the height of this triangle, here's what we need to know. And here's what we do know. But here's what we have to find out. We know from right here to where this player is located is exactly 200 pixels. I know that because my player's Y is at 200. My character's Y is exactly at 350, okay? So what we need to do is find the distance between 350 and 200. So to do that, we can take our character's Y and subtract it from our player's Y. Or in other words, 350 minus 200 will give us this value for A. Okay? Should be 150, right? Okay? Now we can do the same thing. Once we find A, then we'll square it. But we can do the same thing to find B, the base of this right triangle. We know that from right here, the origin, to where our character is located, we know that that's 100 pixels. And from right here to where our player is located, we know that that's 200 pixels. So we can find the distance between these 2 points by taking our character's X and subtracting it from our player's X. So now that we actually know what A and B are, we can take that block of code from subtracting CY and PY and subtracting CX and PX. We can take that and square them, make it A squared. So you're actually going to have 300 minus 200 in a block, and then you're going to take that whole block and square that block. Same thing with 100 minus 200. You're going to square that. And then if we use the adding function and put those two, A squared plus B squared, inside there, we'll have a grand total of C squared. Now C squared doesn't do us a whole lot because we just want to find out regular C, the distance between these two. So in order to unsquare numbers, we use this, it's actually called the radical sign.
Oh yeah.
Okay? And it's the square root of a number. So if we look at just simple math right here, I'll just go over here. 7 squared is 7 times 7, which is 49. If we want to unsquare 49, we do the radical symbol, or the square root of 49, and we'll get 7. So you can do the same thing. C times C is C squared. If we want to find the square root of C squared, we then would get C, which is our actual distance. Okay? So once you finish your distance function, and believe me, it's like a big block of code. You got to subtract the 2. You got to do 350 minus 200. Then after that, you have to square it. Then you have to add it to 100 minus 200 squared. And then you got to put that whole thing and find the square root of all of that. Okay? Once you do that, then you have the distance. And the unfortunate thing is once you get the distance function done, you expect something to happen to your game. Guess what? Nothing happens because all your computer's doing is just calculating the distance between your players. That's all it's doing. Okay? Then in puzzle 3 in lesson 20, you're actually using your distance function inside of your collide function to say, anytime my distance is less than 100 pixels, we want a collision to happen. Because we know that each character, each sprite, is exactly 50 pixels. Okay? So if I'm 50 pixels and another sprite is 50 pixels, if we have them less than 100, we want that collision to happen. Okay? So you're going to have to actually use a Boolean. You have to say that it's less than, and you want your distance to be less than 100. And everything should be working on your game.